Okay, so we're going to do inequalities now with a straight line and a parabola. Okay, because that's the ones you get most of the time in the exams when you do graphs. This is actually part of graphs, okay, functions, which we're going to do later. But while we're doing inequalities, it's good to have a look at how it works on a graph. Okay, so let's look at this one first. 2x plus 3 big or equal to 0. Okay, so the straight line, y equal to 2x plus 3. There's the straight line, y equal to 2x plus 3. Okay, this part, obviously, if you think about it, there's the x-axis. Everything below the x-axis is where it's negative. Everything above the x-axis is where it's positive. So this part here is where the graph, the straight line is below. So it's negative, it's small or equal to 0. And then that part is where it's big or equal to 0. So if the question says, where is 2x plus 3 big or equal to 0? Obviously, it's going to be that part. It's from that point between -1 and -2 on. When you go to the right, you get positive values for y. Okay? So remember, it's y equal to this. So let's say, just to give you an example, let's say I put 1, x equal to 1 in here. 2 times 1 is 2, 2 plus 3 is 5, which is positive. And you can see that, it's positive. When I put 1 in, I get a positive answer out. When I put 3 in, 2 times 3 is 6, 6 plus 3 is 9. So when I put 3 in, I get 9 out, which is a positive answer. But let's say I put -2 in. 2 times -2 is -4. -4 plus 3 is -1. Then I get a negative answer. That's why we say, when we ask you where's the graph big or equal to 0, where you can see it on the graph. If you have a graph, you can see it. This part is where it's bigger or equal to 0. So it's from -1,5 onwards. So the answer will just be for this one, x bigger or equal to -1,5. Okay, so it's x, there's -1,5, x must be bigger or equal to -1,5 to get positive answers. Okay, does it make sense? Okay, you could have done this one algebraically. We did it looking at the graph. Algebraically, what you would have done is take the 3 over, becomes -3, and then divide by 2. So then when you divide by 2, -3 divided by 2 is -1,5. So you can do it algebraically, or you can do it by looking at the graph. Okay? But you have to see the relation between the two, that it's the same thing. Okay? That's why algebra is like your basis, your foundation, and graphs is where we're heading. We start with graphs, we start with algebra to get that foundation, and then we move on to graphs. So later in the year, we're going to start looking more at graphs. Okay, let's look at the second one. X squared minus 4x plus 3 is smaller than 0. So this is a parabola now. Okay, this parabola, okay, y equal to x squared minus 4x plus 3. Okay, and if you look at this parabola, you can see this part here. Let's make it green. This part is where the graph is smaller than 0. Okay, even when you substitute, like let's say you put 2 into the equation, 2 squared is 4, minus 4 times 2 is -8, so 4 minus 8 is -4 plus 3 is -1. So then you get -1 out, your output value. So when we say, where's the graph smaller than 0, the graph we're referring to the output values. Because it's y is equal to this, and y is your output values. So where are the output values going to be smaller than 0? Does that make sense? Putting it like that. My y values are my output values. Where will my output values be smaller than 0? Okay, so it's going to be between 1 and 3. That part, between 1 and 3 is where the output values will be. So x must be between 1 and 3. Okay, bigger, x bigger than 1, smaller than 3. Between them, my output values will be smaller than 0. Okay. Now the next one, I'm putting an interesting one here. Where's the parabola smaller than the straight line? Okay, so let's look at that. Let's make it blue. the parabola smaller than the straight line. So here's the straight line. Let's start here. Which one is bigger there at -2? The parabola or the straight line? Which one is bigger? The parabola. The parabola is up there. The straight line is down here. So the straight line is lower. The question is, where is the parabola smaller? Where is the parabola smaller than the straight line? So here the parabola is bigger than the straight line. Now let's move on. Let's go here somewhere. Now the straight line is here. The parabola is there. If I look at x equal to 2, I must go up to get to the straight line, and I must go down to get to the parabola. So the parabola is lower than the straight line. Okay? Let's say we look at 4. At 4, if I go up, I get to the parabola first, and then I have to go higher to get to the straight line. So at x equal to 4, my parabola is lower than the straight line. So it's smaller than the straight line. Okay? So from where did that start happening? From here. From there all the way to there. This blue part is the part where the parabola is below. Okay, this whole part here is where the parabola is below the straight line. It's smaller than the straight line. Okay, so it's from there up to there. That means it's from x equal to 0 up to x equal to 6. I'm looking at my x values, okay, always the x value. So from 0 to 6, the parabola is lower than the straight line. So where's the parabola smaller than the straight line? For x bigger than 0 and smaller than 6. And that's my answer.